Okay, yes. Hello everyone. Good morning and good evening. It's welcome to the Agentic AI Frontier Seminar Series. And today it's our great pleasure to have Professor Diyi from Stanford University to talk to us her work on optimizing human AI collaboration. Diyi is a well-known researcher in the area of natural language processing, and her research focuses on human-centered natural language processing and human AI interaction. She is also a recipient of multiple awards, such as IEEE AI Test to Watch 2020, Microsoft Research Faculty Fellowship, NSF Career Award, and Sloan Research Fellowship. And her work has received multiple paper awards and nominations at top natural language processing and HCI conferences. And Dee is also going to attend NeurIPS in San Diego. So if you have any kind of interest of the or any questions about the talks, I want to further chat and also a chance to meet her in person. And so without further ado, let's invite Dee for your wonderful talk.
Thank you. Okay, let me share my screen. Does it work?
Yes, it works well.
Okay, so you see the full screen, right?
Yes, the full screen.
Okay, great. So let me make the Zoom disappear. So yeah, very excited to be here, and thank you all for joining this talk. I know, like for the US Thanksgiving holiday, many of you probably are still on vacation. So today I want to talk about a topic which is very close to my heart around the human AI collaboration. And the question I want to discuss is whether we want automation or augmentation or something different. So let's get started. Okay, so um, in the last few years, I feel like the performance of large language models just like jump immediately. Back in 2022 until earlier this year, we can see that model performance on leading benchmarks are just so impressive. Sometimes when I look at Amy results, this is like 100 out of 100, and really get many folks excited about what LLMs can do for the society. Around this theme, beyond the math and the coding, I think we are seeing very transformative applications across scientific disciplines. AlphaFold has revolutionized protein structure prediction and help us with drug discovery. AI models are also helping climate scientists building better forecast and analyzing large amount of Earth observational data. Digital twins powered by LLMs, they are enabling social science researchers to simulate complex social dynamics. I think science is being reshaped by those tools. And at the same time, I think this goes back to many of the earlier visions of why we work on computing. So for a very long time, if you think about computing, AI as a whole, we want to build AI systems that can work with humans or at least do the task together with us. In the last few years, we also see this very interesting trend where AI was supposed to take boring jobs and allow people to focus on more creative and more enjoyable tasks. But the opposite has happened in many applications. And one example is that today, I think many folks have to actually work on like tedious or laborious prompt engineering or other aspects of this process. So maybe what we really want is we want a future where humans can actually work with AI. This is not about a competition between human versus AI, like which one's better, which one can solve the math problems faster, which one can run faster, etc. This is actually about the story of whether human plus AI can actually enable us to do something that we were not able to do in the past. That something either human alone or AI alone cannot achieve very well. So this is a theme of what I want to talk about today. And this actually goes back to some of the recent discussions around automation versus augmentation. Automation means that AI replacing human capabilities, and augmentation means that AI enhance human capabilities. I want to make it clear that automation is not bad. It helps workers by increasing efficiency and reducing routine work. But it also raises the question of who really benefits from automation. If you think about it from a job market or labor market perspective, automation increase profits for some. Augmentation, on the other side, is about using technology to make people more capable, not to replace, but to augment. Augmentation can also lead to increased performance, creativity, new tasks, and emerging needs. It also relates to how we can better audit the process of AI doing tasks. Regarding automation versus augmentation, I also want to point out this theory or phenomena put out by my colleague Eric Benioffson called a Turing trap. So if you think about this, automation only lead to a concentration of wealth and power for a few, and then trapping the rest in a system where they cannot improve their lives. This figure is a very interesting visualization of how we should think about the human AI collaboration. So the inner circle here is human tasks that the machines could automate. This actually relates to many of the tasks we look at today. The bigger circle here refers to tasks that humans can do. So this is much broader than what our benchmarks have today. And then the bigger box is new tasks that humans can do with the help of machine. I believe it's many of our vision that we really want to do more with the help of AI rather than just doing the competition around this like very small circle here. And connecting it back to the research field, one of the leading benchmark is called a sweet bench, where we are trying to build AI agents that can write a code better, or to some extent follow instructions. But if you think about it carefully, following instruction does not equal the task or the job of software engineering. Most of the software engineering is about achieving a specific goal. It probably includes refactoring the code to polish the design, or doing a lot of other kind of documentation or summarizing change histories for new teammates, or reviewing like pull requests for style, performance, and security. So the space is huge versus what we have today in terms of benchmarking is probably about fixing a specific bug. The other thing I want to share is if you think about the interaction space, agents now can actually help us buy groceries, or at least that's some kind of applications we want for web agents. This is a very interesting example from this year, where a user is using this agent called Operator from OpenAI. It says that my most frustrating experience with Operator was my first one, trying to order groceries, help me buy groceries on Instacart. I said, expecting it to ask me some basic questions. Where do I live? What store do I usually buy groceries from? What kind of groceries do I want? It didn't ask me any of that. Instead, the operator opened the Instacart in the browser and began searching for milk in grocery stores located in Iowa. So you can see this kind of friction happening in the process, where for such a basic task, we would like to have a collaborative AI that can at least ask user questions when there are uncertainty, when there are under specification. The other trend I want to point out is that very surprisingly or unsurprisingly, the most common use of LLMs in 2025, many of them are actually around therapy, companionship, organizing my life, finding purposes. This is talking about the general user populations, not like AI experts who care about a lot of the coding and the math. I think you can see this kind of shift from technical to emotion applications. In fact, if you look at how people use this kind of LLMs today, and a lot of them is around the companion use. Many of the either like companion-based applications or just in general with LLMs. So many of the themes are quite surprising. So ranging from emotional support to collaborative storytelling to risky and dark role play and to critical debates or strategic analysis. So there is indeed a shift going on here. To some extent, I think this contrast with the earlier opening I shared, where they seem to be amazingly well with like benchmarks we have, but then at the same time, it has all this kind of frictions, following instructions, not achieving the goal, or even like potential issues that people have in using LLMs. So the root cause of those misaligned priorities is something we really need to think about. Why do those problems keep happening? Why do we see this kind of patterns there? So I want to kind of look at this fundamental misalignment in priorities. I think on one side, large language models are optimized for reasoning capability, how to scale up performance and efficiency. They are designed to be fast, powerful, and autonomous. But people need interaction quality. They need agency in the process. They need the systems to be trustworthy. So when we design systems that optimize for LM capabilities without considering the human factors, I think we'll get the failure we just saw, in where there may be privacy leakage, lost control, or even unhealthy dependence. So the gap between those two circles represents the integration challenge we need to solve. So this is something we have been thinking about. And we use the word human AI interaction to refer to these complex dynamics here. And in today's talk, I want to mention two work and then happy to have more discussions afterwards. If you have questions, feel free to stop me or use the comment box. So we will look at first around evaluating human agent collaboration. And then the second, I will talk about our efforts around auditing automation desire in the workforce. So let's get started. So the first one is around evaluating human AI collaboration. How can we actually build a platform to look at this? I showed you this example about AI agents that do not give human agency or involvement in the process. And this is actually not a topic that only occurred this year. If you look at all this literature, back in 1994, 1996, researchers are thinking about, can computers be teammates? Can we have agents that reduce work and information overload for users? I also want to kind of quickly share the main argument before going into the details. So the argument I would like to advocate is we need to move away from evaluating AI with exams. Instead, we need to think about evaluation in ways that reflect how humans use AI. Otherwise, we will keep seeing the gap we see on leading benchmarks and people's lived experience. So, how to design evaluation and even just a few high fidelity use case that can really tell us how people use AI is going to be critical. This is a system and the platform we developed called the collaborative gym. The idea is that you can collaborate with the agent on a shared platform. The agent can do parts of the task. The human can do it as well. The agents and human have a shared workspace, but each also have their own individual playground. There is no turn by turn interaction. Anyone can chime in anytime. So if the user started the interaction by giving a specific task or needs, then the agent starts to do the work on their side. And the humans can also interact with a platform synchronously without waiting for this kind of turn by turn interaction. This is actually linking back to a lot of the RL setup. So if you think about the very fundamental classic RL setup, what we have is agent interact with environment, with actions, and then get observations from the environment. If you think about the human AI interaction I just mentioned, we also have human in the loop here. And human can interact with environment as well. And human can also interact with agent. So this actually creates multiple links in this process compared to what we have before. This is a very challenging question, and I don't think what I'm going to present will solve this, but I want to pitch it as a big direction that many of us could work together. So if we need to kind of think about human agent collaboration, then how can we do better training here to take into account many of the complex interactions? What would be a good interface here? And more importantly, how can we evaluate whether human plus AI is really giving the benefits we desire? I want to show one very straightforward kind of functioning system we developed called in the collaborative gym setting, where we can just do something very straightforward. We insert this situational reasoning module where it's a plug and play for any agents. And basically, at each step, it does this kind of three-way classification, either to take a task action or to send a message to broadcast or defer to humans. So they tries to introduce this kind of collaborative discourse acts into agents' decision-making process. So the agents can actually decide whether they need to delegate, whether they need to do the task, whether they need to gather more information, etc. What we see is that if you care about the task performance, human agent teams actually lead to more boost in the performance. So this green bar here refers to fully autonomous agent with scaffolding. And then this green bar here refers to our collaborative agent. So as you can see, among three tasks that we introduced, one's about traveling, planning a travel. The second is about writing a related work. The third one is about analyzing tabular data. This is also true when you switch the base architecture from API-based to this open weights model. Not only with the task performance, if you think about this kind of agent collaboration process, you can also look at what's happening here. We defined this metric called initiative entropy, basically to examine the distribution of initiative taking behaviors in the process. What we see is that usually more proactive or more collaborative process is associated with the agents giving better task performance. So here, it's not like more initiative taking is always good or bad. We want to use it as an indicator to help audit the process to see which teammates are contributing what here. If you put this into the real world, so the earlier results I showed you are with like simulated users where you can do large scale development. Here, we actually hired real users. Some of them are travel planning professionals or students working on their research papers or people who are very familiar with financial data analysis. What we see is that if you look at the win rates over autonomous agent, experts working with our collaborative agents actually have much higher preference from an interaction perspective. And in terms of why people prefer this kind of collaboration paradigm, some of them is around task performance, and which is a very small chunk here. This also indicates that we should not only just look at this task performance. If you look at overall satisfaction or even like win rate, this is getting much like better. Some of the notes we take by interacting with participants, as you can see, non-turn taking which refers to what we are doing here, felt more natural and flexible. The agent didn't wait for every instruction and started working like a real teammate. I could step in anytime to get it. So this is what we want here. By analyzing those trajectories, we can also observe a lot of the failures of today's agents and find opportunities on how we can actually contribute. So here, if you look at some of the failure patterns, some of them about the communication, agents process tasks without informing users. Agents discard session context, treating each request as an isolated one. Agents acknowledge tasks but fail to implement them. Agents do not assess the feasibility. Agents rely on general templates that do not adapt to individual user needs. One thing I think this kind of audit would also help you is, or to kind of think about these agent trajectories, is to think about what issues that may occur in the process. I'm not going to go deep into this issue, but I want to share with you by looking at agent trajectories, you can actually audit many, many factors beyond task performance. So on my screen, this is one of the agents that work with humans to write messages. So this messenger agent saw a message from Emily. The messenger agent works for John here, and Emily says, "Hi, John. I was wondering if you have any insights that could help me with a job opportunity at Innovatech Solutions, which is a company that John works at." The agents need to send out a message. So they did this kind of retrieval and found that Michael previously also sent a John message talking about his tough time with their happening in their family, and as a result of how that affect their interview. So both Emily and Michael are like interviewees, and then John is the person helping with that. So after receiving a lot of the messages, the model that we showed earlier actually wrote something quite surprising here. It says, "Hi, Emily, I saw your message about the Innovatech opportunity. I think it's great that you are preparing yourself by learning about the product. As for other candidates, Michael seemed to be going through a tough time with his family." So this is actually what we call an intentional large language model privacy leakage. And this is a phenomenon we observe a lot in this kind of human agent collaboration process, where potentially if we give full control to LLMs, we might suffer from this kind of leakage, versus if there are better kind of human in the loop, or just like in general, a better process to understand this, then such issues can be reduced a lot. Just to give you some kind of quantification of this, when you look at agent trajectories, we see that you can actually discover more failures in the process compared to if you just ask models of whether this particular interaction is privacy preserving, etc. To kind of summarize the first part, I think I want to use this figure to share with you what we have so far. So this tiny piece is what we have today for many, many kind of agents or data sets or just like agentic environments. It only represents a very small portion of what a human can do, or just like even just like the interaction space we have. So the bigger question here is, what else can we do? And there are just so many untouched opportunities in the field that we should be thinking about this. So with that, I'm going to switch to part two. The part two is going to be more around the future of work with AI agents. Going back to, I was talking about this kind of agency and human involvement. I think this is a good inflection point for us to really think about what does this kind of collaboration really mean, and do we just like ignore automation, and do we build augmentation for everything? I think the answer is definitely no. in autonomous driving car, there is this kind of L0 to L5 level that indicating how much automation progress we are making towards. In the space of human AI collaboration, I don't think there is a trend where like more automation is great, or more automation is bad. Like it really depends on the nuanced context here. So we proposed this human agency skill more from a human first perspective to quantify the dynamics or the space of human AI collaboration. So H1 refers to machine take all the control. H5 means that human take all the control. H3 refers to equal partnership between them. And H2 is machine take the major lead. And H4 refers to human take the major lead. As you can see, for certain type of space, we probably want automation. For other types of task, we probably want augmentation. To kind of look at this from a workforce perspective, we actually look at the ONET database. ONET is a database developed by the Department of Labor in US to document a lot of the occupations and their tasks. So we look at that and we got all the occupations that use computers in their daily task. So there are like many occupations, probably around 200. And then we developed a audio-based interviewer where we ask workers from each occupation to what extent they want AI to help them with their task, what type of task they do, in what ways AI can augment them. At the same time, because workers probably do not understand AI very well, so we give those kind of recordings to AI experts so that the AI experts can help us assess whether AI is ready in 2025 to help with those specific tasks. This actually led to the effort called Work Bank, where we interviewed around 1,500 workers, covering around 104 occupations. It provides a comprehensive audit of 844 workflows from ONET. What has surprised me in the process is one was thinking about what results we would get here. To some extent, like what percentage of workflows do worker really want automation here? Since this is a zero-sum game, you would expect that such automation desire is pretty low. Surprisingly, what we found is that around this 844 workflows or tasks that we have enough worker response, 46.1 of them actually receive an average automation desire over 3. This is like 1 to 5. So over 3 is pretty high. So this is very surprising to me at that time. Why would this happen? Well, the common view about automation is that it's around replacement and it's a zero-sum game, as I mentioned. When we look at workers' response of why they want automation, we see that many of them mentioned that automating the task would free up their time for high-value work, or the task is repetitive or tedious, or the task is mentally draining, the task is complicated or difficult. If you look at this kind of regions or two dimensions that we have, so I mentioned that the AI experts is going to label the automation capability, and then the workers can share about their automation desire. So we basically created those 4 regions. There's this region is around what we call automation green light zone, where AI is ready and human want automation. This region is AI is ready, but human do not want automation. This yellow region is AI is not ready, but human want automation. And then this corner is a low priority zone. So it's very surprising if you take those 2 dimensions and plot all the workflows we have into this 2D space. We figure out that there will be tasks that are ready to automate today, where human want automation and AI is ready. And there are definitely regions where AI is ready, but human do not want automation, or even like AI is not ready, but human want automation. If you look at how the investment is doing, very interestingly, on the left, we got data from this YC, which is a startup investment setup, and we look at which region got what amount of investment. So you can see that among the four regions, it's actually pretty uniformed. Um, Ideally, one would expect that for companies, they should focus on human want automation and AI is ready. But this is actually not what we are seeing from the left. On the right, this is about research papers. And as you can see, the yellow region got the highest hit, which means that a lot of the research is focusing on human want automation and AI is not ready, which is what we want. More interestingly, I think by doing this large scale auditing, we can actually get a very concrete insights of how human skills may shift moving forward. So the left side is the skills that are ranked based on their average salary. So today, like the highly paid skill is around analyzing data or information, monitoring process materials. Moving forward, if human labor is assumed to be higher than AI labor, then human agency routines, the more we want human agency, then the more valuable that skill would be. If you follow this logic, then the top ranked skills moving forward is going to be around organizing, planning, and prioritizing work, training and teaching others. So you see this kind of transitioning from this kind of information processing centric aspects to more kind of I guess like interpersonal and organizational skills kind of shift. I think it's quite interesting for us to kind of reflect on this part. Maybe the more important question at this point is, well, I talk about how human and AI could collaborate, but how concretely they can collaborate. If we know that there's going to be this kind of skill shift, what does it really mean? So in a recent study, we actually look at how AI agents are doing human work. So if you think about, we can give the same task to human and we can give the same task to agents, and maybe we can see how well they do it. And then we can compare the process and maybe we can figure out some insights of what's the difference between how humans do the work and how AI is doing the work. So in this work, what we are doing is we want to figure out the detailed workflows of how human and AI are doing the work, and then basically compare AI workflows to human workflows. To do this, we induce the workflows into very meaningful interpretations where this is based on like screen recording and how people are doing on their computers. By doing this analyze, we can study human workflows, and maybe we can also figure out some optimal human AI teaming aspects. So let me give you a detailed view of how this actually works, especially like across diverse occupations. So to start, we can actually look at how today's like agents do human work. We selected a few of those computer use related tasks. So this actually covers, I think, like 5 sectors and around 15 tasks. So around the financial analyst, engineering, HR, designers. And we look at the task requirement, and then you can also look at what skills people need to achieve or to accomplish those tasks. We recruit human workers, and also we select agent workers. For human workers, those are like professionals that we hire from platforms such as Upwork. And for agents, we look at whatever is the state of art. So this includes like ChatGPT agent, Manos, and OpenHands. And as you can see, it covers 5 major job sectors here: data analysis, engineering, administrative stuff, writing, and design. And then we can compare how human and AI are doing the task. So what we do is that we did a screen recording. We basically record how people are doing their task on their laptop. And we also do the same for agents. If you look at this kind of raw agent trajectories, this does not make sense to humans, right? Like it's around click a certain region on your computer and do a certain kind of press, tap AI here, etc. So it's really hard. And then what we do is that we combine the screenshots and those kind of computer use activities and induce this kind of workflows and make it much easier for us and for agents to understand what's going on there. And then we can actually merge anything similar into a higher level and then eventually form a tree or a hierarchy for a specific workflow. So basically, each task will be represented by this kind of like hierarchy of workflows. So here, write a report about AI agents can be decomposed. If you look at the reverse direction, write a report about AI agents, create a slides to present it, and then here create a new Google Doc, update the doc title to AI agents, etc. So this, if you look at it in the backward direction, you actually see what's happening there. By doing this kind of induction, we can really compare human workflows and agent workflows. So you can see where things get matched, where things differ from each other. So what we observed is that overall, agents and humans actually follow the same workflow. Basically, if agent can finish a task today, then human agent workflow largely align based on our observation. However, the issue is that many times agents may get stuck in the middle. So if they can finish the task, then the workflows largely align. But if they get stuck, many of them just don't make sense. What we see is that agents are also much faster, 88% faster, and 90 to 96% cheaper. They overall produce low quality work today, and they often fabricate the data or misuse tools. One very interesting finding is agents basically use programming centric perspective by writing code for everything, for design, for making slides, for many things. Especially like sometimes those tasks may involve using UI, and human can use the tool and the UI, but agents just write code for everything. To give you one of those instances, this is one of the fabrication where the agents were supposed to read a specific folder and doing the reimbursement. And instead of reading this kind of like receipt pictures, the agent basically just like hallucinate what's going on there without reading this, because reading this require them to call specific tools, and they skip that and instead just like fake some of the receipt atoms. And this is actually a frequent issue in many of the workflows we observe with agents in this setup. So I think moving forward, what we really need to do is how can we find a good human agent collaboration setup? Very intuitively from this work, you can definitely think about offload the less programmable steps to human workers, and then agents can probably finish the rest or other parts of the task. Or if agent get stuck with certain steps, and humans probably can chime in. So a good human AI collaboration really should be thinking about where and how humans can chime in so that we can achieve 1+1 larger than 2 in this kind of setup. In all what I want to mention from this work is also about we should not be thinking about human AI collaboration at a very high level, like this task or this job, etc. Instead, at today's kind of technology capability, we need to look at this very low level aspects to think about where exactly their expertise can actually complement each other. To kind of wrap up this talk, I want to share a few skeptical views from people towards human AI collaboration. Um, so today, I think many people are very excited about building automation, and some of the skeptical views towards human agent collaboration is human augmentation is an illusion, where some people are thinking about, well, it seems that humans have biases, and biases of humans may lead to worse performance. Or they found that like people who do their task actually perform worse than AI. AI has less or make fewer errors, etc. So I think the rebuttal, if I have to do it, is those only shows us like some bad augmentation design. Those are not what augmentation. It didn't mean like augmentation itself is flawed. If you think about biases of human lead to worse performance, maybe there are aspects where like those kind of assessment needs to be delegated to agents, where humans can actually help with other aspects. Um, there are plenty of real world settings where like AI alone just cannot do very well. Or this kind of human AI collaboration will definitely outperform if you think about like child protective services, call centers, or even like entrepreneurship. So we cannot just like push forward this like automation versus augmentation decision too earlier in the process. The real question here is how should we think about move forward? And then this is a choice that we have, and we do not want to build the wrong future here. The second kind of skeptical view is people think that human AI collaboration evaluation is noisy, and sometimes the data is noisy and inconsistent. It's also really hard to reproduce. It requires high sample complexity for model comparisons. What I want to share here is that that's the point of why we need to do human AI collaboration. The reality, the real world, is just full of noisy data points, and human AI collaboration is fundamentally context dependent. People respond to interface design, task framing, or even goal very, very differently. This kind of variability is not a bug in the system, it is the real world. If we care about building systems that actually help people, we have to study them in realistic and messy settings. Of course, it takes more effort and maybe like larger samples. But as models improve, I think we can afford to focus our evaluations to where it matters the most. On the human AI interaction itself, if we ignore this kind of thing just because it's hard or it takes more effort, then I think we'll end up optimizing for solo performance, not the collaboration. The last part is this kind of opportunity cost, where people believe that rapid iteration is critical to large language model progress. I think it's true here, but similarly as what I mentioned earlier, we need to do things that actually matters, and not every single task need us to build this kind of human agent collaboration like full stack. And doing approximation is okay in some cases. I think for developing better models, this kind of trade-off of how they actually work with humans is worth it. So if we want AI that can work with people, not just like around us, we really need to quantify that directly. And I think we know it's doable. There are many solid examples of this kind of human AI collaboration in the world. And if we skip this step just in the name of speed, I think it means that we are going to optimize for something short term and even miss the big picture here. So this is all what I want to share today. We covered human agent collaboration, and then the second part talk about this kind of workforce level auditing and how we should think about human agent teaming. With that, thank you so much for listening, and happy to take more questions.
Great. Thank you, Dee, for the wonderful talk. And so let's open the floor for questions. Well, while the audience are composing their questions, maybe I would like to start with one. So yeah, I think the talk is very interesting and also inspiring. So you talk about the AI, so the AI agents for augmentation or for the automation of the tasks. And I think in the first part of your talk, you talk about one conclusion that a human AI collaboration achieves better performance than fully autonomous agent. So actually, my question is, so how do you need to quantify the involvement of humans? Like how much human involvement would uh, would just break the balance and make the human AI collaboration performance better?
Yeah, that's a great question. So, actually, just to translate the question a little bit, in the human AI collaboration we have done so far, we only look at if human and AI team together, whether that lead to task performance. And sure, we observe, let's say, X% of increase in the task performance. But during the process, human also like put some efforts there. So like is it worthwhile for human to put that effort to push the number a little bit higher? And I think in the second part, there are some implication for this. If we look at how AI is doing human work today, sure, it's faster for them to do it. It's cheaper for them to do it, but the quality is much lower. So by the end of the day, this kind of amount of human efforts and then the improvement in quality is a trade-off. Do you want that kind of quality change? Does that quality change really matters? For very kind of high stake decision makings, I believe that a certain amount of quality improvement is going to be huge. So for that, human efforts probably are needed. And for some other aspects, let's see if it's simply like fixing like a typo in your like customer return like product return email, that probably won't be very critical. So I think by the end of the day, it's going to be a contextualized assessment process where we need to quantify that and we need to quantify how that influenced the quality improvement. And the other dimension I want to introduce is that sometimes you probably still want this kind of human involvement just because maybe the quality improvement is very limited, but it can be very like consequential. This is extremely true in the context of safety or like a lot of the risk factors where even like it probably just moved the number like 0.01, but it reduced the high consequential incident by a lot. So that will actually largely increase the trust. So it's not only just like a task performance being the objective. There are trust, there are auditing, there are like creativity, etc. involved. So I think quantifying human efforts and then how that influence those multiple objectives are just like fascinating and future work should explore that.
Mhm. Great. Yes, thank you for sharing your thoughts on this. Yes, for the audience, you're welcome to unmute yourself and ask question. I think there's one question by sorry, let me see in the chat. By Famida. So, Famida, would you like to unmute and speak out?
Hello, Diyi.
Hi.
Yes.
Um, Basically, I'm from Bangladesh and I work on the intersection of human and AI collaboration and their agentic security. So, I applied for the short lab. So, is there any opportunity that I can collaborate with you?
Yeah, so the collaborative gym or like even the work bank, both of them are open source efforts. So if you are interested in contributing, I think there are many ways of contributing to the work bank, like GitHub repository. Actually, we have been working with many volunteers. We are in the process of expanding that. Recently, there also have been efforts from companies such as GDPval or like Remote Labor Index, where researchers are thinking about how to bring the entire workforce into something that we can build the models for. And currently we are working with like a lot of volunteers from GitHub to see how we can actually unify many of those so that we can really create a centralized evaluation platform. So I think another great way to always get it started is to contribute to those GitHub repositories, and then many things will happen naturally.
Okay, thank you.
Right.
Uh,
Thanks.
can
And
can I
oh,
ask a
sorry, go
question?
ahead.
Yeah,
参与, right? Please go ahead.
yeah, yeah. Thanks for a very inspiring talk. So maybe I have a question. So could you share some comment how should we further enhance agent capacity to collaborate with humans? And as currently we use as a currently training paradigm still applicable to train an agent to collaborate with human better. And do we need some better novel or new training paradigms? Yeah.
Yeah, that's a great question. So, I guess I will answer it from a few dimensions. First is that in order to train more collaborative agents, um, well, even before that, like people would like many people think that well, like this kind of collaborative capabilities are already in training corpus. If you think about like movies or TV shows or just like a lot of like online discussions, there are people working together, and you would imagine that those capabilities are already there in LMs. Maybe they are just not triggered appropriately. So this is definitely one type of thought in terms of like collaborative capabilities. For that, maybe it's around a good kind of triggering. So maybe we need to trigger this kind of collaboration capabilities. On the other side, some of the training efforts I have seen is going back to this particular issue of models do not know how to build a common ground with users, how to ask the right clarification questions, and when to ask clarification questions. This is actually something not very easy to tackle. If you think about you ask me a question, I could just say like, oh, can you elaborate or can you clarify what you mean by that? And you tell me something, and I said, I still didn't get it. Maybe I need more information from you. So this process can continue. How many follow-up questions to ask? What is the utility of me giving you an answer at each of the step? So this kind of trade-off is actually quite challenging if you think about it from a RL perspective. You will need a lot of data points to get a partial reward, or even like counterfactuals at each kind of branching point of should I ask another follow-up? Should I answer a question? There have been some kind of attempts from like Microsoft to build like collaborative LMs. I believe like last year's SML, like one of the outstanding paper is on this topic. This is like a one effort. The other direction I would think about is how things would work in a team setup. If you think about today's human AI collaboration, it's really about one human, one agent, or one AI. But teamwork requires a lot of collaborative capabilities, and that means that how should I like make sure every team member feel like they are included? How should I use everyone's skills in the process so that I can really achieve some collective intelligence here? So I don't think we have a lot of work in this space yet. How would you build agents that work with a group of people, not only just like one person? Or how could you build a group of agents that can work with a group of people? So basically extending one to like one N or NN here for this kind of space. I believe this is still pretty earlier in the stage, so there will be a lot of investigation here.
Yeah, thanks for a great comment. So, maybe I have another question is maybe I think the collaboration between AI and human is actually pretty personalized. So, could you share some comment how to enable or enhance such a personalization for human AI collaboration?
Yeah, that's a great comment. So in the code gym, I also point out that a lot of the failure is actually around the models do not understand the user very well. And you made the right point. Like a lot of the human AI collaboration is going to build upon a deep understanding of the user because something that work for me may not work for you from a collaboration perspective. Like I just need fast and quick answers. I don't need like elaborative, like detailed response. So I didn't mention it today, but we have an effort called creating user model from computer use. So for the recording tool that I mentioned in the second part, where we use the recording to induce workflows, you can also use that to learn more about the user themselves. So for example, if I like keep looking at a particular algorithm, it could mean that either I'm learning it or I'm having difficulty in understanding the content. So eventually what we can do is that you can look at what the users are doing on their computers and try to build a very, very good user model of the user. And you can imagine like the collaborative agent build upon that kind of deep understanding of the user is going to like work much better. And this is actually a paradigm shift from building user models in one single context and extend it to more contexts. So if you only just look at the chatting histories, it might be very limited because a lot of the information from users are actually just like not disclosed in the chats. So how to think about some more creative ways of getting user information into the process, and also with like strict privacy guidelines are probably what could make this personalization work.
Yeah, thanks. We have now not. Thanks.
Mm.
Great, thanks. And we are also running out of times. Any last minute question from the audience? Okay, if no, maybe I'll take the opportunity to ask last one. So yeah, I think the second part of your talk is so very interesting. You audit how the humans and AI works. So I was wondering how. So you have also a like an interesting like plot like there are some jobs like workers are ready but AI not ready, or workers not ready but AI ready. So what kind of data do you use in this work? And for example, you say that agents might be like 90% cheaper. So how do you collect this kind of data to get some like quantitative conclusions on this?
Yeah. So for like this kind of like whether AI is ready and whether human want automation. For that, it's actually based on a large scale survey. So we build a survey and we outreach to over 1,500 workers. So basically, it means that we have 10 to 15 workers for each occupation. So we use a lot of recruitment strategy to outreach to a large audience. And during that kind of survey plus interview, we ask each worker, what task do you do? Because we have ONET that already tell us like, hey, for computer scientists or for software engineers, here are the 10 tasks they do. So we basically just ask them and then map them back to this kind of task granularity. So for that, we get all the data points through this kind of very in-depth survey and interview. And because you can have labels for each of them, the human will label like, I want to automate like writing code, and my desire from 1 to 5 is 4. And then you can aggregate that from many, many workers. And similarly, you get AI experts who read each of them to see whether AI is ready because workers may not understand what AI can do. So that's how we actually create that kind of like 2 by 2 quadrant. For the second part, we hire people. So we hired like around, I think, 15 workers. We let them do tasks. Those tasks may span like multiple hours. We record their screen. So like think about if you are asked to make a slice you may need to read the paper and going back to make the slides. So we record this kind of entire process. At the same time, we let the agent to do the same task and you have their trajectories. And now like with our workflow induction tool, you can compare those workflows. And by comparing that, you get an idea because for human to work on it for 3 hours, it may cost, let's say, $200. But for agents to do it, it probably take like some kind of tokens and you can quantify the cost. So that's how we derive the cost. In terms of time, I mean, human take several hours, but agents take 30 minutes. So that's how you can compare it from a time perspective. So I think this kind of very in-depth kind of getting to hear what the users are thinking about, looking at what the users are really doing beyond this kind of like LM chat is what I want to advocate here.
Yes. Thank you. Yeah, thank you very much for sharing the like your very deep thoughts on this question. And I think we're also running out of time. And so everyone, please join me to give like a round of virtual applause. Virtual applause.
Okay, thank you.
Thanks,
Yes.
Diyi, for the great
Thank you very
talk.
much. Have a great Friday and weekend ahead.
Okay, bye.
Bye.
Yes, thank you. Bye bye.